是那镜子，不像你不曾秘密。我还不肯相信，没有你，我的笑更美丽。那天听你在电话里略带抱歉的关心，我嘟的一声，写的比你说分手彻底。泪湿的衣洗干净，阳光里晒干回忆。折好了伤心，明天戒指和快乐出去。这爱的城市虽然拥挤，如果真的遇见你，你不必压抑，我的笑它无法代替。离开你，我才发现自己那爱笑的眼睛，流过泪，像躲不过的暴风雨，淋湿的昨天想起。离开你，我才找回自己那爱笑的眼睛。再见，爱情，我一定让自己决定。泪湿的衣洗干净，阳光里晒干回忆。折好了伤心，明天戒指和快乐出去。这爱的城市虽然拥挤，如果真的遇见你，你不必压抑，我的笑它无法代替。离开你，我才发现自己那爱笑的眼睛，流过泪，像一眼看旧电影，是我不小心而已。离开你，我才找回自己那爱笑的眼睛。再见到底，我一定让自己坚定。离开你，我才发现自己那爱笑的眼睛，流过泪，像躲不过的暴风雨，淋湿的昨天忘记。离开你，我才找回自己那爱笑的眼睛。再见，爱情，我一定让自己坚定。再见到你，我一定让自己假装很坚定。
Hi everyone.
Hello, sir.
Hello,
Morning.
Okay, so guys, do you know if you have any final exam on the last week of December? Do you know that? Have you ever heard any arrangement for other courses for the final exam? Do you know that? On the last week of December, from December 27th to 31st, any final exam on this week? No?
No, Laushi, we have only final project in
We
another
are having
subject.
project, Laushi. We are having final project.
Okay, okay. So, according to the arrangement of the university, our final exam will be arranged on the week after we finish our course. So, next week is our last class, final class. So, our final exam will be arranged on the fifth week of this month. So that is from December 27th to 31st. And then do you have any courses or classes on Monday this time? During this time? Do you have class on Monday?
On Monday, we don't have any classes.
Okay, no classes. Okay, good, good. So maybe the final exam for
No,
our.
Loshi, China Panorama class will held
We
in
have
Monday.
class also.
Professor
Oh,
guest.
okay. Different majors have different classes, right?
Yes, Loshi.
Yeah, okay. So, uh,
Maybe
uh,
29 or 30 is good day for us, Loshi.
okay. So let me check. Okay, so the same time, let me check. That is December 30th. That day is maybe okay for everyone. Let me write on the whiteboard. Um, from the same time. So okay. So this time, anyone have any classes?
No, Loshi, it's good. Better.
Okay, that is the time we have class, right? So, maybe the time, this time it will be our final exam. So please be prepared for the final exam. And I have shared the sample test on the WeChat group. But the files can be only saved for maybe 7 days or shorter. So maybe some students cannot open that sample again. So now I will resend the sample again to the WeChat group. So the first thing, okay, I have resent the sample in the WeChat group. Yes. So first, please everyone download the file. That is a very important file, and I think everyone can open it, right? In the WeChat group. I
Yes,
just
Loshi, sample question.
Yes,
yes,
Loshi.
yes,
Yes,
yes.
also.
Because some students asked me if there is any way or any similar questions for the final paper. Uh, the questions on the sample that is a question very similar to the final paper. So this file is very important for all of you to have a general review. So the first thing you have to download the file, and then if we have time today, maybe we can complete the first part one. And for the rest part of the test, you have to finish it by yourself during this week before we have class next week. And next week, we will explain every question for you, and I will show some similar questions on the answer sheet for this test. So if you want to pass this course, I think everyone wants to pass the course, right? So you have to first complete the test by yourself and make every question If you have any doubt about the questions on the test, on the sample, you can discuss with me or your classmates to make every question clear. And that is very important for you to pass the final exam. Okay, guys, am I clear?
Yes, Laoshi.
Okay.
Laoshi,
Yeah.
how much time we will get for the exam?
2 hours.
Only 2 hours?
Yeah, only 2 hours here. This
Only
is the
2 hours,
time.
100 marks exam.
Yeah, 2 hours. And you don't have to copy the questions. You just send me the answer sheet. For the first 2 parts, only give me the results, the final answer, without procedure. And other parts, I also want the procedure for other questions. Okay,
Okay,
so
Laoshi.
if when I explain the test, the sample, I will show you how you present your answer sheet. Okay, guys. So for this week, first we will solve the homework I left last week, and some students tell me that the homework is really difficult. So how do you think, other guys? So do you think the homework is really
Yeah, Laoshi, it's
difficult?
very difficult.
Yes,
Very
Lakshmi.
difficult.
Very difficult.
Okay, okay. So
Yeah, Lakshmi,
That's quite
especially the
difficult.
first one is very difficult.
yeah, especially the first one, right?
Yeah, Laoshi.
But actually, the first one, okay, I will show you how to solve the first one, and you will find that is not so difficult. So let's first solve the question number 1. That is to calculate the definite integral from -1 to 1, and the integral that is 2x squared plus x cosine x by 1 plus square root of 1 minus x squared dx. Okay, so for this question, I have gave you guys the hint last week. Remember that? I have told you to use the property for odd function on a symmetric interval. So here you will find the interval that is from -1 to 1, right? And then first we can separate the integrand to 2 parts. That is from -1 to 1. The first part, that is 2x squared by 1 plus a square root of 1 minus x squared. And the second part, that is x times cosine x by 1 plus square root of 1 minus x squared dx. Okay, so first, if you have figured out the interval that is from -1 to 1, right? And that is a very important clue for you, because if the interval that is from -1 to 1, you can check the function, the integrand here. If it is an odd function, that means the result of this definite integral that is 0. Remember that? We have learned this property, and it is a very important property here from -a to a. If fx, that is an odd function, that means f of -x equals minus f of x. So first you have to check for the first part. This is part 1 function. You can check that we substitute minus x into this function. So here you can find f sub 1 minus x. That means we substitute -1 in minus x into this function. So that is 2 times minus x squared. 1 plus square root of 1 minus x squared, right? So we know that is the same, 2x squared, because here the power is 2. So that is 1 plus 1 minus x squared, that equals to f1 of x. So this is f1x. So we know if f of minus x equals f of x, we call it even function. So here, the property that is from minus a to a f of x dx equals 2 from 0 to a f of x dx, right? So this function, that is an even function. And then we can check the second part. This part, that is, we call it f2 minus x here equals here minus x times cosine minus x. 1 plus square root of 1 minus x squared. And then here, minus x, that is minus x here. And cosine minus x, you should know that cosine, the function cosine x, that is an even function we usually use. That means cosine minus x equals cosine x. So that means cosine x. And here 1 plus square root of 1 minus x squared. So you can see there is a minus sign, and the rest of the function is the same as f2x, right? This part.
Bluetooth
This is f2x. So here you can know that equals minus f2x. So here means f2x, this function, it is an odd function. So from the property here, if the function that is an odd function and the interval here is symmetric here, so the result that is 0. So here you don't have to calculate this part because it is always 0 here. So here we know the original interval here that equals from -1 to 1. We only have to check this part. That is 2x squared by 1 plus square root of 1 minus x squared dx. So for now, can you understand, guys? Do you have any questions here? Why we don't have to calculate this part? Can you understand here? Okay.
Yes, Laushi, got it, Laushi.
Yeah. So here we simplify the integrand from this form to a simple one, right? And then, as here, we have known that this function, that is an even function. So it equals 2 times from 0 to 1, 2x squared, 1 plus square root of 1 minus x squared dx here. So we can take the constant 2 out. So that equals 4 times from 0 to 1, x0 by 1 plus square root of, okay, here. So here you have to figure out another thing. That is, we have x squared here, and we have x squared here, right? So if these two x squared can be cancelled, that is very good for simplifying this integrand, right? So here we use a way that we usually use here. That is, this is the original, right? And then we can we can product we can product 1 minus square root of 1 minus x squared, both up and down. Because we don't want this square root, right? So we can we can time this factor both up and down, and then that equals here, these two factor equals 1 squared minus square root of 1 minus x squared, right? And here, that is x squared times 1 minus, that is the same here. And then we know here 1 minus here square root power 2, that can be cancelled. So that equals here, numerator the same. And then we have 1 minus x squared, right? So here you can see 1 minus 1 plus x squared, that is. So that is, I will write 1 minus 1 plus x squared. So 1 minus 1 can be cancelled. Here, that is x squared. So it can be cancelled here. So we have that equals what? That equals 1 minus square root of 1 minus x squared here. So the integral now can be changed to from 0 to 1, 1 minus square root of 1 minus x squared dx here. So for this part, anyone have any questions? For this part, to simplify the integrand here.
No, Laushi, there is no question.
You don't have question, right?
Yes, Laushi.
Okay, good. Others, do you have any questions? No? Okay, so here you can see the integration, the integrand, that is 1 minus square root of 1 minus x squared, right? And we separate it to two parts again. The first part, that is from 0 to 1, the integrand here, that is 1, right? dx. And the second, that is minus 4 times from 0 to 1, square root of 1 minus x squared dx here. So we separate it to two parts again here. And I think you know how to calculate this part, right? And this part, that equals 4 times 1. Why? Because from A to B, k dx, and that equals k times b minus a. We have learned that the constant k can be taken out, that is from A to B dx, right? And we can use the theorem, that is k times x from A to B, right? X from A to B, and that equals k times b minus a here. So we can calculate the result for this integral directly. That is 1 times 1 minus 0, so that's 1 here. And then we minus 4 times from 0 to 1, square root of 1 minus x squared dx. So for this definite integral, we have calculated before when we don't have any formulas to solve definite integral. But we can also calculate it we use the geometric meaning of the definite integral. Remember that the geometric meaning of the definite integral means the area of the region, right? So here, and later I will show you another way. If you don't know the geometric meaning, how to calculate this definite integral. So now we want to calculate from 0 to 1 square root of 1 minus x squared dx here, right? And the first way we use the geometric meaning. So you have to know it means, because here square root means always larger or equal to 0, right? So that is area, and from 0, here is 0 to 1, x equals 1. X equals 1, this vertical line. And the lower bounded, that is the x-axis. And here we will find the curve here. And the curve here, that means the integrand y equals square root of 1 minus x squared here. One minus x squared here. And remember that we have talked about it before. If you cannot figure out what is the graph of this function, you can first step calculate the power 2 of two sides. So that is 1 minus x squared, right? So here y is larger or equal to 0 because y means square root. So here you know that is x squared plus y squared equals 1, right? So that is a circle where the center is the original point and the radius, that is 1. So you know it is a circle here. It is a circle here. And we want y always larger than 0. So that means half of the circle, right? Y is always larger than 0. And then don't forget here, the interval that is from 0 to 1. That means x that is in the interval from 0 to 1 means x is larger than 0, smaller than 1. Here means x is larger than 0, smaller than 1. So the region that is larger than 0, smaller than 1, this part. Here is the region here. So you know the area, the result of this definite integral means 1 by 4 the area of this circle. So that it means pi r squared means 1 squared. So that is pi by 4 here. And you can calculate, you can get the result of this definite integral without calculating this definite integral, right? Actually. And then if you don't know that, if you don't know this definite integral means a circle, and here you can use another way to solve it. Here we also want to calculate from 0 to 1 square root of 1 minus x squared dx. Here we always use a function to substitute this x. And the function we always use, that is sine function. So we can let x be sine t. And here, x that is from 0 to 1. So here means t, if x equals 0, t means 0. If x means 1, t means pi by 2. So here we know that if we let x be sine t, that t should be from 0 to pi by 2 here. And dx here, dx means cosine t dt, right? So this definite integral, we use the substitution rule here. And we can write it as from 0 to pi by 2. And here that is square root of 1 minus sine t squared. And dx means cosine t dt, right? Here, cosine t dt. So that equals from 0 to pi by 2 here. And then 1 minus sine t squared means cosine t squared. And t that is from 0 to pi means cosine t that is always larger or equal to 0. So here we know that is cosine t and cosine t dt here, right? So here means cosine t squared here. Dt. And of course, here we have to calculate this definite integral. And actually, we have solved this kind of definite integral before. And we use another relationship between cosine x and cosine 2x. So here, cosine 2t, because cosine 2t equals 2 times cosine t squared minus 1. So we know that cosine t squared equals cosine 2t plus 1 by 2. So that is changed to from 0 to pi by 2. Here, cosine 2t plus 1 dt here. Here, dt. And we can take the constant 1 by 2 out. So here is from 0 to pi by 2. Cosine 2t plus 1 dt. And we separate it to two parts. The first part, that is 1 by 2 from 0 to pi by 2, 1 dt. This part, right? And then plus 1 by 2 from 0 to pi by 2, cosine 2t dt here. And I think the first part, this part, we know that is 1 by 2 times the length of this interval, right? So that is pi by 2 minus 0 means pi by 2 here. And the second part, that is plus here. You have to calculate this definite integral again. So now you will find if you can use the geometric meaning, then it is so easy to calculate it, right? If you don't know the geometric meaning, of course you can calculate it, but that will be a little bit complicated here. And then this part. For this part, I will write here. That is from 0 to pi by 2, cosine 2t dt. Here we use the substitution rule for calculating indefinite integral, and we have practiced this kind of question many times. So here, first you can let u be 2t here, because we want to use this formula, x dx cosine x dx. That equals sine x, right? just plus c here. And here, we let u be 2t, and du means 2 dt, right? And then don't forget to change the interval here, because t takes from 0 to pi by 2. So u takes from, we substitute u 0 here, means 0 to pi, right? 0 to pi. So it equals from 0 to pi cosine u. Then dt here means 1 by 2 du. So that equals 1 by 2 from 0 to pi cosine u du. And that equals 1 by 2 sine u, right? And from 0 to pi here, from 0 to pi here. So that equals 1 by 2 sine pi minus sine 0. And sine pi equals sine 0 equals 0. So that is 0 here. 0 here. So that equals pi by 4. And we have got the same result, right? Pi by 4. Pi by 4. Here. So if we know that is pi by 4, and we know the final result for it, because this part that is pi by 4. So the final result for the first question, okay, so that is 4 minus pi. 4 minus pi. So you will find that this question, we use minus scales we have learned. Okay. Let's retry it again from the beginning. First, we use the property, this part. For the first part, we use the property of the odd function on a symmetric interval to simplify the integrand to only one part, right? And then we use the property of the even function to make it to make the interval to be from 0 to 1. And then we simplify the integrand here. And it is a very common way we use to simplify a function with the square root. So here we simplify the integrand to this type. And then we separate it to two parts. The first part that is easy, and for the second part that we use the geometric meaning. I think that is the most fast way to solve this definite integral, right? So here, that is pi by 4. We can got it. But if you don't know it, you have to calculate this definite integral step by step. But here, actually, there is another skill to calculate it. First, you have to substitute this by sine t. It is the same. So you can change it to this step. And if you found here is a skill we usually use to calculate the function with the integrand with higher power of sine and cosine function. So that is from 0 to pi by 2 sine t power n dt equals from 0 to pi by 2 cosine t power n dt. And here, there are two ways to solve it. You have to check the constant, the power here, n, if it is an odd or even constant here. So here you should know. I will give you the example directly. For example, if n equals 4 here, so from 0 to pi by 2 sine power 4 dt and equals from 0 to pi by 2 cosine t power 4 dt. Here, it will be equal to 4, 3, 2, 1. And then if the constant here, that is an odd function, and you should know that you have to time here, you have to time pi by 2 here. So if n, the power, and that is an even constant here, you can use this result directly. So that equals n minus 1 times n minus 1, n minus 2, and then so on. And here, don't forget to times pi by 2 here. So for example, here, the power is 2, right? The power is 2. So the result should be, you can use this formula directly. That will be 2, 1, and then times pi by 2 here. 8 must be pi by 4. For any even constant, you can use this formula directly. So if here, I want you to calculate, for example, pi by 2 sine t power 8 dt cosine t power 8 dt, it should be equal to 8, 7, 6, 5, 4, 3, 2, 1, and then time pi by 2. So it must be the final result. Can you understand how I use this formula, guys? So you can use this formula directly if you found the definite integral here that is in the same form as it. So you can use it directly, and you can get the final result pi by 4 directly without these steps. Okay, so you can use it. But if the constant, the power here, that is odd, for example, n equals 3 here, n equals 3 here, and then that should be from 0 to pi by 2 sine t power 3 dt equals from 0 to pi by 2 cosine t power 3 dt. So that should be 3, 2, 1. That is the final result. So that must be 2 by 3. So if you are doubtful about the result, you can calculate this definite integral by yourself, and you can check if the final result, that is 2 by 3 here. So the formula that is always from n, then minus 1, then Oh, sorry, here I make mistake here. That is yeah, n minus 2 and minus 3, right? Or it can be cancelled. So here, the formula that always be n minus 1, then n minus 2, n minus 3. For here, 4, 3, 2, 1, 6, 7, 8, 7, 6, 5, right? Always minus 1. And then the difference between these two formula, that is, if the power that is even, then don't forget to time pi by 2 at the end of the result. And if the power that is odd, it is the final result here. So guys, can you tell me that if I want you to calculate, for example, from 0 to pi by 2, sine t power 5 dt. So do you know how to calculate the final result without calculating this definite integral? That should be from, can you follow me, guys? And that equals 5 here, then what constant here? 4, right? 5, 4, and 3, 2, 1. So this is the final result for this definite integral. So this is a very quick way to calculate this kind of definite integral to have the same form here. It is a formula we usually use to calculate, to simplify the calculating. So if
if n equals odd, so that I cannot multiply pi by 2, but even I can multiply pi by 2, right?
Pardon, sorry.
N equaled odd number, so that I cannot multiply n by 2, pi by 2, but it's even, I multiply pi by 2.
Yes. So here is the solution for the first question. So here I have give you another skill actually. And how to get this formula, actually we use the method integration by parts, and we will explain later how to use integration by parts in calculating the definite integrals. Okay, so this is the solution for the first one. Remember this formula. It is very useful to calculating definite integral, and it is really easy to remember it, right? So remember this formula. And then question number 2.
Hello, Shay.
Yes?
Can we use this short technique during exam without any explanation?
Of course, you can use it directly.
Okay, Hello, Shay, thank you.
But I will not show the formula on the final exam. Okay, so you have to remember that.
Yeah, sure.
Okay, so number 2. Number 2, that is from minus 2 to 2, x plus square root of 4 minus x squared dx. And this question is not that difficult, not that complicated as the first one, right? So the first, we use the formula to expand this integrand. So that equals x squared plus 2x times 4 minus x squared, and then plus a square root of 4 minus x squared dx, right? This is the first step. And then it equals from -2 to 2, x squared, we don't change it, and then we plus this part. This part should be 4 minus x squared, right? And then we plus 2x. Okay, here you can see x squared can be cancelled, right? So the integrand here, that is two part actually. The first part, that is 4. So I will write it separately. The first, that is dx, 4 dx. And then we plus 2 times from -2 to 2, x times 4 minus x squared dx. And of course, you think that calculating this definite integral, that is not easy, right? But if anyone found that we don't have to calculate it, we don't have to calculate why. Anyone knows why? The reason why I said we don't have to calculate it. The result of this definite integral must be 0. Why? Can
Maybe
anyone?
x variable is 0, maybe.
X be 0?
X variable. Maybe constant, it's constant.
It's a constant, or which part is constant? Which part is constant?
Maybe x variable is 0. That's why it should be 0.
Not exactly.
It's the odd function.
Yeah, exactly. We should focus on the integrand here. Here, the integrand, the function, that is x times square root of 4 minus x squared, right? So here, I will write it beside this definite integral. So if fx, that is x times square root of 4 minus x squared. So you can substitute minus x here. Minus x here, here minus x, right? And then 4 minus x squared. So that is minus x times square root of 4 minus x squared. And it is f of x, right? So that equals minus f of x. This means this function, it's an odd function. And the interval here, that is from -2 to 2. So first, guys, before you calculate the definite integral, you first should observe if the interval, that is symmetric, and if the function, that is an odd function. If the definite integral satisfies these two conditions, it must be 0 here. You don't have to calculate 8. So here equals from -2 to 2, 4 dx. And the easiest way to calculate it, that is 4 times the length of the interval. The length of the interval, that should be 2 minus -2 here. So that is 4 times 4, right? 4 times 4, right? So that should be right, 16 here. So can you understand this question, guys? Any doubt here?
No.
Okay. So here is the solution for the second one, and then the last one here. number 3 here, and that is from 3/4 to 1 dx by square root of 1 minus x minus 1, right? So for this question, I have gave you the hint. You can treat this square root as a whole. So first, we use the substitution rule to let maybe u or t, and the letter is okay. So here you can let t be 1 minus, x, square root of x, 1 minus x here. And here you will find that you have to know dx, right? So we know if t equals square root of 1 minus x, then t squared equals 1 minus x, right? So that means x equals what? Equals 1 minus t squared. That means dx equals d 1 minus t squared, so that is 2t dt here. That means dx equals 2t dt here. And the last step, don't forget to change the interval. The interval that is x from 3/4 to 1. That means t should be taken first. We substitute 3/4 here. That means square root of 1/4, so means 1/2, right? 2, 0 here, 0 here. 1 minus 1, 0, right? So to 0. Here we change the integral to from 1/2 to 0. And then here, this should be t minus 1, 2t dt here. 2t dt here. Sorry, here. I forgot the minus sign here, right? Minus sign. Don't forget it. So here is a minus sign here. And the first, I use this minus sign. I use this minus sign to exchange the lower limit and upper limit here. So that equals from 0 to 1/2, 2t, t minus 1, dt here. And then we can take the constant 2 out. So that equals from 0 to 1/2, t by t minus 1 dt. And this definite integral, or we don't see the interval here, this indefinite integral we have learned before how to calculate it. A usual way we solve it here, because we know t minus 1 here. So we can first minus 1, then plus 1 to make these two parts the same. So I will rewrite it again. That is from 2 times from 0 to 1/2. And then we can change it to two parts. The first part, that is t minus 1 by t minus 1. And then the second part, that is 1 by t minus 1 here. Right? And t minus 1 can be cancelled. So that is 1 plus 1 by t minus 1 dt here. And we can, of course, separate it to two parts. The first, that is 2 times from 0 to 1/2 dt. And then plus 2 times from 0 to 1/2, 1 by t minus 1 dt here. So the first part, that is easy, right? That means 2 times the length of the interval, so that is 1 by 2. And plus the second part, we have to calculate it. Here, 2 can be cancelled, so that is 1 here, right? And now we will calculate this part. And this part, we can use the substitution rule again. To make you clear, I will write it step by step here. First, we can let u be t minus 1. Then you will know that t equals u plus 1, right? So dt equals du here. And the last step to change the interval here, t means from 0 to 1 by 2. So u means from, first we substitute 0 here, that means minus 1, right? And then 1 by 2 here to minus 1 by 2. So we know that equals from minus 1 to minus 1 by 2 here, and then that is 1 by u here, du here, because dt equals du. And we can use the formula directly, that is ln absolute value of u, right? And then from minus 1 to minus 1 by 2. So that equals ln absolute value of minus 1 by 2 and minus ln absolute value of minus 1 here. So here means ln 1 by 2 minus ln 1. And ln 1 equals 0. So that equals ln 1 by 2. And here you can use the property of the function ln again. We have introduced before. Ln a by b equals ln a minus ln b. So it equals ln 1 minus ln 2. And ln 1 equals 0. So that equals minus ln 2 here. And you can leave it as ln 1 by 2. It is also okay. So you know the result here, that should be 1 plus 2 times here minus ln 2. So that equals 1 minus 2 times ln 2 here. So we can see we use substitution rule twice here for this question. Oh, I will make it small to let you see the whole procedure of this question. Okay. So any questions about this one? Any doubt here?
Laoshi, should we write d here? Definite interval.
Yeah. I here. That means this definite integral here. I just use a letter to present it.
Laoshi, if I write d, is it okay?
Okay, of course.
Okay, Laoshi, thank you.
Okay. And other questions?
I have a question.
Okay.
I have a question about this part. I just like where substitution 0 to 2 minus 1, and then we're solving it, yeah?
Not minus 1 here. That is because we substitute t equals 0 here, right? Okay, here. We substitute 0 to t here. So u start from 0 minus 1. So u start from minus 1.
Okay, okay.
Yes,
Got it.
because for this part, the variable that is u, so we have to find the interval for u. So we change the interval here.
Got it.
Okay, okay. And other questions, guys? Okay, relax. These 3 questions are homework, right? So even if it is a little bit difficult, that not means you cannot solve the definite integral in the final paper, okay? And you can see from the WeChat group, and we have showed the, let me check here. For example, the question in the test paper number 7, part 3, number 7. As you can see, the question there, that is not so complicated, right? This is for homework. So I will give you some challenge here, right? Okay, here are the solution for the homework last week. And it really spent our much time. So here, I have mentioned that there is another way to solve the definite integral, that is the integration by parts, right? So we have learned the integration by parts as we calculate the indefinite integral, and that is the same way for the definite integral. So another skill here for calculating definite integral, that is integration by parts. So here I will show you how we use the method integration by parts when we calculate definite integral here. I will give you an example directly, that is from 0 to 1, x, ex, dx. So can you remember how we use integration by parts? That is the formula here, u dv, right? And equals uv minus, we exchange the places of these 2 parts, u v du. Here, v du. Remember that? That is integration by parts we have learned when calculating indefinite integral, right? And I have gave you a list how we choose which function to be u and which function to be v. Remember that? The order, remember that? That is important when we calculating integration by parts. So the order first, that is inverse trig function. I will give you the function directly to let it clear. For example, the first, that is arc sine x. If you find arc sine x in the integrand here, it should be u. So the former had the priority, right? So the first, that is arc sine. And then the second, that is the log function, so ln x. And then power function, so x squared, or we usually have x here, right? And number 4, that is expert function, so that is e power x. And then the last part, that is sine function, sine x. So here is the other. The former had the priority here. So for this integrand, you will find x, ex, right? And of course, x is former. So we choose u be the function x, right? So you have to leave x here, and you should know that ex dx equals what? Equals dex, right? Dex. So we know here v means ex here, right? So the first step, you have to make it clear which function to be u, which function to be v, to be v. So here that is from 0 to 1, and then x be u, dex, right? So I will mark here u, v, right? And then we use this formula. And for the definite integral, there is only one difference. That is, we have the lower limit and upper limit, right? So here, for the formula here, the first part, uv, you should substitute the limit here. And the second, the same interval here. And u times v from a to b means you first substitute b here. That means ub, vb, then minus ua, va here. And then minus from a to b, v du here. So we know that equals u times v means x times ex, then from 0 to 1, and then minus from 0 to 1, we exchange the places of u and v. So here that is v, that is ex, dx here. So for this step, anyone has any questions here? Any questions here?
No,
Can you repeat again, please, from the last line?
Last line here, right?
Yeah.
Yeah, okay. Here, when we have decided which function is u and which function is v, then we should choose, we should use this formula. Okay, for this formula, I will make it clear, write it here again. That is from A to B. U dv equals what? First, we times uv and from A to B, and then minus from A to B, the same interval. We exchange it. We exchange the places of u and v. And u times v from A to B means you first substitute b into the function. So that means ub vb. And then minus, we substitute a into the function. So that is ua va. Then minus this definite integral. Okay, so here we choose ubx and vbex. So first times xex. That is from 0 to 1. Same, 0 to 1. Same here, the interval. And then minus, we just exchange the places of u and v. So here, v, ex, and ux, we just exchange the places here. So we come to this step here. Okay, and then we substitute first. This function, we can get the result directly. First, we substitute 1 into this function. That means 1 times e power 1, right? And then minus 0. That means 0 times e power 0. And then here, minus from 0 to 1, ex dx. And then here you will find 0 times e0 means 0. So here that is e, right? E power 1 means e. And then minus here, this is 0 here. From 0 to 1, ex dx. First, we find an antiderivative that is ex, right? And from 0 to 1. So we have that equals e minus here. Don't forget how to calculate it. First, we substitute the upper limit into this function. That means e power 1. And then we substitute x into this function. That means e power 0. E power 0 means 1, not 0. Remember that? So that equals e minus 1, right? So that equals 1 here. We have the final result that is 1. So any questions here for the integration by parts?
Yeah, let's see, can you repeat again from the blue line?
From where?
From the blue line.
Oh, a blue line, okay.
Yeah.
Okay, so here, a second step, right, Jack?
Yeah.
Yeah, okay. Okay, so here, we just use, we have learned how to calculate it. We substitute the upper limit first. This is 1 upper limit, right? So into this function, that means x equals 1. So that is 1 times e power 1, right? And then minus, we substitute 0 here. Here we use the theorem. We have learned how to calculate a definite integral. Remember that? That equals, we first find an antiderivative, and then we substitute upper limit, that means FB, and minus the lower limit, that means FA, right? So capital FB minus capital FA. So here means we substitute 1 first, that is the upper limit, and then minus the lower limit here. So that is this part. And the second part here, that is a definite integral. So first find an antiderivative for e power x. Of course, that is e power x, right? So we use this theorem to substitute 1 first, that is e power 1, and then we substitute 0, that is e power 0, and e power 0 means 1, e power 1 means e, so e can be cancelled here. We can get the result that is 1 here. And other questions for integration by parts? No questions? Okay, I will show you another example here. Another example here. Let me find one. 1 minute. I will find another question here. Okay. This one. I will write here. From 1 to e, x ln x dx. Okay, this question is the question on the test paper from 1 to e x times ln x dx. That is on the test paper question number 7, 3. Question number 7 here. So you can try first. Okay, let's solve this question together. Here, I found some students make a little mistake, that is, maybe make the formula confused. Here, ln x prime or d by dx here, d ln x, that equals 1 by x, right? That not means ln x dx equals d1 by x. That is not correct. So here, this is the first point. And then, actually, we don't know ln x dx equals what, right? So here we have to use integration by parts. And if we want to use integration by parts from the order here, we have seen ln x, right? And another that is x. So ln x, that is the former, right? So we know we should leave ln x here. And that is from 1 to e. We choose ln x as u here. And then dv. So you should know that d what equals x dx, right? So here we just find an antiderivative of x. So that is x squared by 2, right? So we know that is x squared by 2 here, right? So this is v here, this is v here. So we use integration by parts formula, that equals x squared by 2 ln x from 1 to e, right? And then minus from 1 to e, we exchange the places of u and v. So here that is x squared by 2 d ln x, right? And first, we substitute e into the function. That is e squared by 2 times ln e. And then minus, we substitute 1 into this function. So that is 1 by 2 times ln 1, right? And then we minus here. We minus here from 1 to e x squared d ln x. Here, I don't change it here. I first calculate this function. And then that equals ln e equals 1, right? Ln e equals 1. And ln 1 equals 0 here. So the first part, that is e squared by 2. And here that is 0, so minus 0. And then minus from 1 to e, x squared by 2 here, d ln x. d ln x equals ln x prime dx, right? So that equals 1 by x dx. So here we times 1 by x dx here. So we know x can be cancelled here, right? So that equals e squared by 2. We don't change it. And then minus here, 1 from 1 to e, x by 2 dx. And that equals e squared by 2 minus here. You can take 1 by 2 out. So that is from 1 to e x dx, right? So that equals e squared by 2 minus here 1 by 2, right? And here that should be 1 by 2 x squared. right? And then from 1 to e, from 1 to e. So that equals e squared by 2 minus 1 by 2 here. We first substitute e, so that is e squared by 2, and then we substitute 1, so minus 1 by 2. So that equals e squared by 2 minus, we product 1 by 2 separately, so that is minus e squared by 4, and then minus means plus 1 by 4. Okay, many students make mistakes here. That is plus, not minus here. So e squared by 2 minus e squared by 4 equals e squared by 4, and then plus 1 by 4 here. Or you can write as 1 by 4 times e squared plus 1 here. So here is the solution for this question. So any questions here? Any doubt here?
Sir, could you please explain this part?
Okay. Okay, here. We want to put x after d, right? So you have to make it clear. D equals dx, right? Because here that is x dx. And the formula here, that is u dv. So we want to put x after d, differentiation. So here we want to make it clear, d what function equals x dx, right? So how to find this function? Actually, we can use, that is to find an antiderivative of x, right? So we can use the formula, the power formula, that is 1 by n plus 1 x power n plus 1. So here the power is 1 here. So that is 1 by 1 plus 1 x power 1 plus 1. This is the way to find an antiderivative. That is the formula from indefinite integral, right? So that is 1 by 2 x power 2. So we can use it to be the function here. And you can check x power 2 by 2 prime equals 1 by 2 times 2x. So equals x here. That is what we want. So here I use the formula of indefinite integral here because we have learned x power n dx equals 1 by n plus 1 x power n plus 1 plus c here. And you don't have to write plus c here because I only want one antiderivative here. So that is x squared by 2. Can you understand?
Got it, Lao Sư. Thank you.
Okay. Other questions, guys? Okay, no questions? Okay, so after the break, I will give you another 2 exercises for integration by parts. As you have seen, that will be shown, that will be appeared on the final paper, right? So after the break, I will give you other exercises to practice. Okay, so let's have a break, 15 minutes. So please be back after 15 minutes and please remove the circles on the screen. Okay, so let's have a break, guys.
Okay, Lao Sư.
Okay, there is a purple rectangle here. Please remove it.
Oh, sorry, Lao Sư.
Okay. Let's have a break. Hello, guys. Can you hear me?
Yes, Laoshi.
Yes,
Welcome back.
Okay, let's back to class. And I will give you some more exercises here. And the first one, that is the second one. Okay, please solve these three exercises here.
ভাই কি ব্রেক দিছে নাকি ভাই? কি হইতাছে?
Okay, let's solve the question one by one. First, some students make mistakes here. Cos power here that is minus x here. So after many steps, students.
Roshi, your sound is not clear.
Oh,
Your mic is not clear.
okay. How about now?
Here you put
Yes,
it also.
Roshi. Right now it's okay.
Okay. So for the first question, some students make mistakes here. The power here that is minus x here. So after some steps, maybe some students forget the power that is minus x, forgot the sign minus here. So that will lead to a mistake. So let's solve the first one. And that is from 0 to 1, x e power minus x dx. And from the order for choosing the function u, we know that we should choose x as u, right? And then the question is, the function v equals what, right? So here you should know that e power minus x dx equals d what function here, right? And we know that e power x prime equals e power x, right? And if here that is e power minus x here, prime, that will be here. Remember that it is a composite function here. Composite function. So we should use the chain rule here. So that means it equals e power minus x. That is the same, and don't forget minus x prime from outside to inside, right? Remember that. So that will be minus e power minus x. So we know that e power minus x prime equals minus e power minus x, right? That means minus e power minus x prime equals e power minus x, right? So I put the minus sign here. That is equivalent, right? So that means I know this function is what I want here. So minus e power minus x should be v here. So here, don't forget the minus sign. It is very important. So then we know that equals from 0 to 1 x d power d here that is minus e minus x here, right? So x is u and minus e power minus x, that is v here. So we use the formula that is u times v, so means u times v, right? And the limit from 0 to 1. And then minus, we exchange the places of u and v. So that is from 0 to 1 minus e power minus x dx. So here, every step, don't forget the sign minus, okay? And then first, we can substitute 1 into this function. So that means 1 times minus, I can put the sign minus. At first. So here is minus 1 times e power minus 1 here, right? And then minus, we substitute 0 here, 0 times minus e power 0 here. So that is 0, right? And then we minus from 0 to 1, minus e power minus x dx here. So here, the first step here, that is minus e power minus 1. And here, that is 0. So that can be canceled. We don't write it again. And then we know this part. This part, you can put the minus sign outside the integral sign, or you can take it with the function e power minus x. Because we have discussed here that minus e minus x means e minus x, right? And here we want to find, you can use another way here to make it clear. First, you can take the minus sign out, that is plus from 0 to 1, e minus x dx, right? And then to make it clear, you can let t be minus x here, right? If you let t be minus x here, then dt must be equal to minus dx here. We have a minus sign here, and t should be taken from the x taken from 0 to 1, right? So t should be from 0 to minus 1. We substitute 1 here. So that is from 0 to minus 1 here. So we know that can be written as here from 0 to minus 1 here. And e power t here, right? And dx means minus dt here. And we usually write the lower limit is smaller than the upper limit, right? So here I can use this minus sign here to exchange the places of lower and upper limit. So that equals from minus 1 to 0, e power t dt here. So we know that should be e power t from minus 1 to 0. So that equals e power 0 minus e power minus 1 here. So we have that should be minus e power minus 1 plus e power 0 minus e power minus 1. And e power 0 means 1. So that equals 1 minus 2 times e power minus 1. So here is the solution for the first exercise. Any questions here? So this is a question with the confusion here. Don't forget the sign minus here. If here that is e power x, that will be easy, right? But if here is minus x, so every step, don't forget the minus sign here, and here, minus sign. So
How can I get 2 here? 2e to the power minus 1.
2, the last line.
Last line, Laoshi.
Okay, here that is minus e minus 1, power minus 1, right? Here, that is also minus e power minus 1. They are the same.
Okay, Laoshi.
Okay. Or e power minus 1, you can write as 1 by e, right? So that is 2 by e. They're the same. So any questions? Okay, no questions. Let's solve question number 2. Okay, question number 2, that is from 0 to 1. E power square root of x, dx here. So, of course, here, if you see square root of x, that will not be easy to calculate. So, the first step to solve it, we usually use the substitution rule first. So, that means we can let t be square root of x. And then we can see t squared equals x, right? So that means dx equals dt squared. So that equals 2t dt. And if we calculate definite integral, don't forget to change the limit. Change the interval, that is very important. So x that takes from 0 to 1. So we should know that t takes from, if we substitute 0 here, t means 0, right? If we substitute 1 here, t means 1, right? So here that from 0 to 1, e power t dx here means 2t dt. And we can take the constant t 2 out. So that is 2 times from 0 to 1, e power t dt. So here, this type, we usually use integration by parts. So as we know, it is an easy one because here that is power t. So we choose t bu here. So here, and then d, we can directly put e power t after the symbol differentiation, right? So that is e et here. So here we can use the formula that equals 2 here, that is out. And then the first, that is t times et from 0 to 1. And then minus, we exchange the places of t and et here. So we know that equals 2 times this part, we first substitute 1. So that is 1 times e power 1. And minus, we substitute 0 here. And that is 0 times e power 0. And then minus from 0 to 1, et dt. So it equals 0. Here means e, right? E. So that equals 2 times e minus from 0 to 1, et dt. And here we know that equals et, right? And from 0 to 1. So the last step, we substitute first here, first 1, so that is e. And then minus 0 here. That means e power 0. Okay, e power 0 means 1, right? So that equals 2 times e minus e plus 1. Okay, so we get the final result should be 2 here because e can be cancelled. So here is the solution for the second one. We first use the substitution rule, and then we use integration by parts to solve this question. Okay, any questions here?
没有老师。No
Okay,
questions.
okay, good. So the last one that is a little bit difficult. So the third one, that is, I want you to calculate from 0 to 2, f of x minus 1 dx here. But x have different expressions in different intervals here. Okay, in the question, fx equals x sine x 1, x is between 0 and 1, and x squared, when x is between -1 to 0. So here you should know the first thing, that is, we have given you the expression of f of x, but not f of x minus 1. They are different, right? So the first step, if you want to use the expressions here, you have to change it to this tab. So the first step that is very important, that is the key to solve this question, that you should use the substitution rule to let t be x minus 1 to change the form here. So if you let t be x minus 1, you will know that x equals t plus 1, right? So dx equals dt plus 1, that means dt, dx equals dt. And the third step, change the interval. Don't forget this step. X takes from 0 to 2, right? So t takes from, we first substitute 0 here, that means -1. And then we substitute 2 here, that means 1. So the interval here should be from -1 to 1, f of t dt. So now we will solve this definite integral. And we have changed to f of t type because here, okay, I will change the color here. Although I use x here, but you should clear one thing, that is, if I write the letter t here, that is the same. That means f of t, when t is between 0 and 1, then the expression should be t times sine t, right? I just changed the letter here. The expressions are the same. And then if t is between -1 and 0, then should be t squared here, right? So this is another key to solve this question. It is very important. You should know, no matter which letter I change, the result, that is the same. That is the same. And then here, the interval here, that is from -1 to 1. But we know when t is smaller than 0, we should use this expression. When t is larger than 0, we should use the first expression. So they're different. So here, the first step, we should divide the interval first. So that is from -1 to 0, -1 to 0, f of t dt, and plus from 0 to 1, f of t dt. We have learned this property, that is from a to b, f of x dx equals the c, that is a point between a and b. So that from a to c plus from c to b. Okay, so we can divide the interval here. So the first definite integral, when t is between -1 to 0, here we should use this expression. So that means from minus 1 to 0, t squared dt, right? And the second, that means from 0 to 1, t is from 0 to 1, that means the expression should be t sine t dt. So for here, anyone has questions? Anyone has questions? Okay, no, okay, no questions. So here, for the first part, this part, we can calculate directly, use the formula that is 1 by 3 t power 3, right? And from minus 1 to 0. And then the second part here, we should use integration by parts, right? So I will solve it directly. I will solve it separately. So here, we first calculate this part. That means we first substitute 0 here. So that is 0. And then minus, we substitute minus 1 here. That means minus 1 by 3. So the first part, that is 1 by 3, right? This is 1 by 3. And this part, from 0 to 1, t sine t dt here. So from the order, we should choose t bu, and then sine t dt should be minus d minus cosine t, right? Because when we calculate cosine t prime, there will appear 1 minus sign here. So minus can be cancelled. We know that is sine t dt. So here that should be d minus cosine t. And here, oh, sorry, here is t. Okay, so now we use integration by parts. This is u, this is v. So that equals t times minus cosine t from 0 to 1. And then minus from 0 to 1 minus cosine t dt. So don't forget this sign minus here. Okay, and then we substitute the first part, that is 1 times minus cosine 1, and then minus 0, I don't write it, and then minus means plus, right? So plus 0 to 1 cosine t dt. And cosine t dt here means sine t, right? From 0 to 1. So that equals minus cosine 1 plus sine 1, and then minus sine 0. And sine 0 equals 0. So here is sine 1 minus cosine 1. I put sine 1, the positive one, before cosine 1, minus cosine 1 here. So we know the final result of this question should be the first part equals 1 by 3. And the second part equals sine 1 minus cosine 1. So the final result, that should be sine 1, 1 by 3 plus sine 1 minus cosine 1. So here are the solution, the whole solution for question number 7. We should first use substitution rule to separate the interval, and then we take use of different expressions to solve different definite integral here. So any questions here? Any places you don't understand? You can ask me now. Or other places you cannot understand?
Masha, what about this? It's like we're using a rule to change. I don't
Here,
understand.
yeah, when we find v here, cause the formula that is u dv, right? So we want to put sign after the symbol d, right? So we should know sine t dt equals d what? So we have to find this function. Then how to find this function? That is to find an antiderivative here of sine x. That means which function prime equals sine t here. Or that means sine t dt equals which function plus c here. So we know the function, the formula here, that is minus cosine t, right? So here also minus cosine t, and here also minus cosine t here. So we have find minus cosine t here. You can use this way or this way. Each is okay. Other questions, guys?
Well, can we leave sine 1 minus cosine 1 the answer? Or we have
Here,
to
you,
simplify it?
yeah, you just write sine 1 here. Sine 1 minus cosine 1, because sine 1 doesn't mean a special, because 1 here, that is not a special angle, right? So you cannot calculate without a calculator. So you don't have to write the accurate number here. You just write sine 1 minus cosine 1. That is okay.
Okay, Kailash.
Other questions here?
No, sure.
Okay, good. So the last part of our course and our book and our semester, the last part, that is the area, the problem area here. And this part, I think, actually we have learned it, because at the beginning, we learn what is a definite integral. We use the area, right? So we know that if a function, the graph of a function that is above the x-axis, then if here that is a, it is b, the function that is f of x, right? So we know that the area of this region, that should be from a to b, f of x dx, right? Here, the bounded, here, that is bounded by, the region is bounded by this function, f of x, x-axis, and two vertical lines here, x equals a and x equals b. So at the beginning, we learn, okay, so here at the beginning, we learn definite integrals. Here, we know that the geometric meaning of it, that is the area of a region. So here, there are two area questions problems. The first, that is, we call it total area. Actually, that is this case. This case, that is total area. So that means the region is bounded by the function x-axis and two vertical lines. So these two vertical lines gives us the lower limit and upper limit. And the curve, that is the integrand here. So when we calculate this definite integral, that means we calculate the area of this region. So for example, if I gave you a question that is calculate the area bounded by the x-axis and the curve y equals 2 minus x squared. If the question is to calculate this area, so first I will give you the graph, and the graph here, that is like this. This is the curve f of x here. This is the x-axis, 0, y. So for you, I have give you the curve, the x-axis, right? So if you want to write at the expression of definite integral, you should know a and b, the limit, right? So how to get the limit, as you can see, that is this point and this point, right? And how to get these 2 points, you should firstly set how to get these 2 points. That means set y equals to 0, right? That means 6 minus x squared equals to 0. Then we can find these 2 points, because these 2 points means y equals to 0, right? So that means 6 minus x squared equals to 0. So do you know how to calculate the point x here? If I give you the equation x squared plus x minus 6 equals to 0, so can you calculate, can you find x equals to what to make the equation holds?
X equals to n minus 2.
Okay. So here, that means first, that equals x plus 3 times x minus 2 equals to 0, right? So this gives us x1 equals minus 3 and x2 equals 2. So this means this point, that is minus 3, right? And this point, that is 2. So if we want to calculate the area, that should be a definite integral from minus 3 to 2. And the integrand here, that is a function. So the function, that is 6 minus x squared, and then dx. So this question is let us to write down the definite integral expression by ourselves from this question. So you should know the key point, that is to find the limit here. So the limit that is from -3 to 2, and then we know the area that is to calculate this definite integral. And I think this definite integral is not hard, right? So please now calculate it by yourself. That is not hard compared with the previous integrals I gave you, right? So please calculate it by yourself. So what is the result? Here you can use the fundamental theorem together here. So that can be 6x, right? And minus this part, 1 by 2 x squared. And this part, minus 1 by 3 x power 3. And from -3 to 2. So we can put it together and then use fundamental theorem to find antiderivatives. So first, we substitute 2 here, and then we substitute -3 here, right? So the result, that is, okay, do you get the same one? Same result here? 125 by...
Yes, Laushi.
Okay, good. So this is the first occasion, that is, first case, that is the total area. So that means, the total area means the region that is bounded by the function and x-axis. So the key to solve this kind of question, that is to write the expression of definite integral. So this is a very important part. Okay, and then the second case. The second case, that is area between curves. This is the first case, total area. And the second, that is area between curves. Okay, what's the meaning of area between the curves? That is maybe this kind of. Okay, then I will draw the graph here. And this is x-axis, 0, y-axis, and we have two curves. The first curve that is above, we call it function f of x. And we have another curve that is below, and we call it g of x. Oh, y2, okay. So here is vertical line x equals to a, and here is the vertical line x equals to b. So this region, the area of this region, we call it area between curves. So the two curves, that is f of x and g of x, right? So how to calculate, maybe I can call it region 1, okay? How to calculate the area of region 1? So here, you can think of this question this way. First, oh, okay, I will write here. From A to B, here, A to B, f of x dx. Remember, from A to B, f of x dx means which region here? Okay. The region means between the curve and x-axis, right? So, from A to B, f of x dx means, I will shadow it with blue color, this part, right? Between f of x and x-axis. So maybe this region, we call it region 2, the blue one, region 2. And there is another curve. It is from A to B, gx dx. So this expression means which area? Means the region between gx and x-axis. So this part, I use green one to means we call it R3. So guys, this means the area of R3. And this means the area of R2. right? So the question, we want to calculate the area of R1. So from this graph, you can see that the region, the area of the region R1 should be the blue region minus the green region, right? So that should be the blue region area of R2 minus the green region area of R3. So we substitute the expressions here. That means from A to B, f of x dx minus from A to B, gx dx. So because here the interval that they are the same, so we can make it together from A to B, f of x minus g of x dx here. So if we want to calculate the area between curves, then the integrand here should be the above function minus the below function. That as the integrand here. So this is the formula for calculating area between curves. Can you understand, guys? That means the big area minus the small area. Can you understand, guys?
Yes, yes, Lasha.
Okay. So here, I can give you another question. Here, if the question that is to find the area of the region bounded by or enclosed by the curves y equals 2 minus x squared and y equals minus x. Okay, so for this question, I will give you the graph first. Y equals 2 minus x squared, that is the graph like this. And y equals minus x, that is the graph. It is a line, right? Passes the original point. So here is the region. Here is the region. So from the formula above, we know the area should be from this point to this point, right? There are two vertical lines here. So that is from A to B. The integrand here, we use the upper, the above function to minus the lower, the below function. So here, the above, that is y equals 2 minus x squared. The above, the below, that is y equals minus x. So the integrand here, that should be 2 minus x squared minus x, right? dx. Then how to find the lower limit and upper limit? So we should find the common point of these two curves, right? So how to find these two, the common points of these two curves? That means we should know that 2 minus x squared equals minus x, right? To find the common point. This means the first function, and this is the second function. To find the common points, they should be equivalent, right? So that means we have to solve it. So I will give you the standard procedure here. The standard procedure that should be, first, we find the common point. So we should solve the equation first. So that means 2 minus x squared equals minus x. That means x squared minus x minus 2 equals to 0. So this is the common points here. So we know that should be x minus 2 times x plus 1 equals to 0. Right? So x1 equals 2. x2 equals minus 1 here. So we know that this point that is minus 1. And this point that should be 2 here. It also means this is lower limit. And this is upper limit. So now we can write down the expression of definite integral that should be from minus 1 to 2. And the upper, that is 2 minus x squared and minus x dx. Means plus x here from minus 1 to 2. 2 minus x squared plus x dx. And we can use fundamental theorem together to get, that is 2x minus 1 by 3 x power 3 and then plus 1 by 2 x squared from minus 1 to 2. And the last step, we substitute the upper and the lower limit here. So we can find the final result for this question, that is 9 by 2 here. So any questions here for area, how to calculate area between curves? Any questions here? Although this region, we have part of this region below x-axis, right? But you will find in this region, the curve is always above the line, right? So we can always use f of x 2 minus x squared to minus x here, g of x here. So here is how we calculate the area of a bounded region. So any questions here? No? No questions? Okay. So if you don't have any questions, so we have learned all the chapters for Advanced Mathematics 1 this semester. So that is all we will check on the final paper. So as I have told you at the beginning of this class, the sample paper, the test paper, that is very important for you. So I will show you the test. Can you see the test here? Guys?
Yes, Laushi.
Okay. Okay, so can you see the PDF here?
Yes, Laushi.
Yes,
Okay.
Laushi.
Okay, so as you can see on the final paper, on the final exam paper, we will have 1, 2, 5 parts maybe. or 4 parts. Okay, 4 parts. We have 4 parts here. So the first and 2 parts, you only gave me the result, the final result. For example, the first one equals, you only gave me the number here, the constant here, without procedure. And same as part 2, only give me the choice you make. And then for the third and 4 parts here, a calculation problem and the number 4 part, applied problems here, you should give me the procedure, and every step will take marks. So don't give me blank one, okay? So first you have to write down something, then I can pick something correct to give you some mark. That is very important. Don't give me the blank answer sheet. Try to write down. And then for the first part, okay, first part and second part, these 2 parts are some easy questions. So don't think too much about the questions. They are not hard. So try to use the basic knowledge to solve it. So let's solve the first part, these 5 questions. Okay, so first, you can turn on your microphone, and when I ask questions, if you can think about, you have an idea how to solve it, you can ask me. As I repeat again and again, this paper is very important. Okay, it can guide you. After class, gave you the sample question paper. What that means, the papers I have sent twice in the WeChat group. You can download there. And the answers I will give you next week. Okay, after the class, I will explain every question on the class, and I will give you the answer sheet, standard answer sheet after class, okay? For the first part, and for the first questions, remember that? Here, we want to calculate the limit here. So do you remember how to calculate the limit? This question is really easy, and I think everyone can finish it, can work it out. So the first one, calculate as x approaches -1, then the function that is 3x times 2x minus 1. So we know we just substitute -1 into the function. Then we can get the result, right? So guys, please substitution x equals -1 into the function to get the result. So that should be 3 times -1 times -3, right?
9.
9, Master.
Yeah, 9. Yeah. So the first, that is easy, right? So yeah, don't give up.
It's -9.
9, yeah, 9. So
-9.
no, not -9. It equals 9. Here that is, okay, 1 minute. I will write on it directly. Yeah, 9. 9, okay. 1 minute here. Okay, I will write on the files. First, we substitute x equals -1 into the function. So that should be 3 times minus 1 times here minus 2, right? Minus 2 minus 1. So that should be minus 3 times minus 3. So should be 9, not minus 9, 9. That is the result for the first one. Okay, so number two, guys. If gx, it is a function, is larger than 2 minus x squared, smaller than 2 cosine x for all x. So, can you remember how to get as x approaches 0, the limit of gx? Remember that? Because gx is between these two functions for all x, right? So the limit is also between these two functions, right? So that means as x approaches 0, 2 minus x squared, the limit should be 2 minus 0, right? 2. And as x approaches 0, 2 cosine x should be a cosine x here should be 2 times cosine 0, and cosine 0 equals 1, so 2. Okay, so you can see as x approaches 0, the smaller function, the limit of the smaller function, that is 2, and the limit of the larger function, that is also 2. This means as x approaches 0, the limit of this function is also 2 here. The sandwich theorem. Remember that? So here is the result for number 2. Can you understand?
Yes, 老师.
Okay. And number 3. I have given you a function.
6 Loshi, maybe.
So do you know, guys, how to calculate f prime minus 3? You have first calculate what?
F of prime x.
Prime.
You have first calculate f prime x, right? And then substitute minus 3. Yes. So first, fx equals 4 minus x squared. So f prime x equals minus 2x. And then, yeah, we substitute minus 3 here. So it should be
6.
Yeah, 6. Yes, 6. Not hard, right? Don't be afraid of the final paper, okay? Number 4, we skip it. I will explain next week. And we come to number 5. Remember this function? Okay, if y equals it, then find dy by dx. Remember that? We have learned it before we learn how to calculate definite integral here. We have learned 2 types here, actually. The first, that is from a to x, f of t dt, and x prime equals, we just find the integrand, and then we change all the t to x. Remember that? And if here is a function of x, remember that we have to time its prime. So that is from a to, maybe here, that is gx ft dt prime. So that should be f of first. We substitute gx here, and then times gx prime here. So here you should pay attention to the upper limit. If it is x alone, then you just change all the t to x. That is the result. But if it is a function of x, as here, square root of x, you have first substitute it. That is cosine square root of x, and then times square root of x prime here, right? So square root of x prime equals 1 by 2 x power minus 1 by 2. So you can write it as 1 by 2 x squared, right? So that equals 1 by 2 x squared cosine x squared. So for this question, if you have any doubt, I will give you other examples next week. So next week, we don't have much time to give you to calculate one by one. So please finish it before next week we have class, and you don't have to submit to me. Just finish it by yourself and for yourself. And then next week, I will explain one by one. Okay, guys?
Okay, Laoshi.
Okay, so don't forget the date of the final exam. And we still have class next week. Okay, so see you next week.
Okay, Laoshi. Thank you, Laoshi.
Bye.